All right, let's continue with chapter 2. Let's do section 2. We should be able to finish this in this class period, I hope. Me too. So let's talk about this super quick. Might have talked about it the other day. We're doing a lot of similar things in my pre-cal class right now, and sometimes I can't remember if we did it in here or we did it in that class. So I don't know. You tell me if we've done this or not. All right, so what if you had a line that's going through right here? There's a couple things, a couple points that are, I don't know, kind of important that we're going to talk about. And when we went over the homework, we did talk about one of them, was this one right here. What do you think I call that point right there? Now, I don't know how far up I went, so I'm not dealing with any numbers, but I got a name for that. It's the y-intercept, right. It's where that line crosses the y-axis, and so that is called the y-intercept. I'll spell it out for the first time. It's supposed to be an R. Inter, I-N-T-E-R-C-E-P-T. Intercept, all right? That's the y-intercept. So, what's another intercept do you think I'm going to talk about? The x-intercept, exactly right. That point right there, because it crosses the what? The x-axis. This is where it crosses the y-axis. This is the x-axis, so I'm going to call that the x-intercept. All right, and that can come in really handy for us. We did this last year in geometry, so let's do an example. And we're going to do example 1. It's a weird looking E, isn't it? There we go. It's probably not much better. All right, example 1. And we are going to graph. Oh, I got one more thing I want to say about that. I didn't write that down, but let's finish writing this problem, then I'm going to tell you one more thing about that. All right, that's what we're going to do. We're going to graph this using our x and y intercepts. Our x and y, I'll just put int to shorten it. Is that all right? X, just right there. You see the papers, right? Yep. Let's talk about this for a second. This y-intercept. Now, I don't know exactly how far I went up because I didn't put any like little marks or numbers or anything. But this is going up y. So what would the ordered pair be for that point? How far over do we go on the x to get to the y-intercept? We go 0, correct. How far up do we go to get to the y-intercept? Well, we don't know, right? I didn't put any marks on there. So how far up did we go? We go y, right? Up a certain number. Y just stands for a number. We put y because it's going up. Everybody good with that? What about this one right here? What about the x-intercept? We go over in the x direction, correct. It could be positive, negative, x could be whatever. But how far up do we go once we get here? We go 0. So if you notice, check this out. The y, let's do the x-intercept first. The x-intercept, what is 0 when we find the x-intercept? What's 0? Come on. The y, okay? That's the y. What is 0 on the y-intercept? The x is 0, correct? All right. That's what we're going to use when we graph things using intercepts. And it's kind of a method that, myself included, doesn't really use all that often, but it's a lot of times it might be a little bit easier, okay, to use. So what we're going to do is we're going to find the x and y intercept. So let's find the x-intercept first. So if we find the x-intercept, what we're going to do is we're going to set something equal to 0. What are we setting equal to 0 to find the x-intercept? We set the y equal to 0, right, just like what we did. All right? So let's go ahead and do that. Let's find the x-intercept. Let's find where our line crosses the x-axis. You follow what we're trying to do here? Okay, so that's what we're going to do. We're going to find where it crosses the x-axis. I'm looking for that point right there. Now, I don't know if my graph looks like that exactly. Probably not, because I just randomly drew that line. All right, but that's what we're looking for. Where on the x-axis does our line cross? Well, we can find that by setting the y equal to 0. So you take this little equation that they give you right here, and we set the y equal to 0, and we solve for x. So it's 2x plus 3 times 0 equals 6. Once you do these problems, you may not want to even put that 0 in there. You can probably do it in your head, right? 3 times 0 is what? 0. So what's this going to give us? 2x equals 6. Divide both sides by 2. X is 3. Do I just circle 3 and that's my answer? No, because we have to graph it, all right? But we just found our x-intercept. Let's write it as an ordered pair. What's the x-intercept then? 3, not 3y, because I set the y equal to something. What is it? 3, 0. So I can take my graph, go over 3, don't go up at all, right? Up or down at all, and then that's my x-intercept. So I can put that point on the graph. We'll do that in a second, all right? I don't even have my graph up yet, but I will. Let's do the other one. That's the x-intercept. Let's find the what? The y-intercept. So what do you think we're going to do to find the y-intercept? We're going to set the x equal to 0. Good. We're going to set the x equal to 0. So you're going to use that same equation, right? But this time the x is going to be 0. So it's going to be 2 times 0 plus 3y equals 6. 2 times 0 is 0. Divide both sides by 3. So y is what? 2. How do I write my ordered pair? 0, 2. So these two, it's not really my answer, but this is what I'm going to graph. All I have to graph are these 2 points. Graph the 2 points, connect them, I got my line. It's as easy as that. Would you agree? Yeah, let's see. Yeah, good. I still have that. A little extra large, but we'll do that. All right, so let's graph that. We'll do it in another color. All right, so 3, 0, where is that? 1, 2, 3, 0 is right there. 0, 2 is right there. What do we do with those 2 points? Connect them. Now this is a line, okay, there's no restriction or anything. And there you go. You just graphed using the x and y intercepts. It's kind of a way that we don't think about that often, because we are going to learn, let's see, today do we learn it? Yes, we are. You knew this already. You knew it from Algebra 1. You knew it from geometry. Do you remember the slope-intercept form? What's that? Y equals what? mx plus b. Yeah, we know that. And we use that a lot, all right? All right, so let's start talking about that a little bit. Now this line right here has a slant to it. We don't call it a slant. What do we call it? A slope. I'm not going to go through all the details on this. I'm just going to remind you because you've learned this the last 2 years. I'm not going to start from scratch. So we use the letter M to represent the slope. It's kind of weird. Why would you use M? I don't know. Looked it up one time. Actually, nobody really knows 100% where the M came from, why people started using M for slope. They surmise it there's all kinds of different things that people think why it's an M. The one thing that I remember, and I could be way off, but the one thing that I remember when I looked it up is M, there's like a Latin word that kind of means mountain, and it starts with an M, and so that's what they used it, because you go up slopes on mountains. I figure that sounds good to me. That sounds logical, doesn't it? So that's how I'll think about it. I don't know 100% why they used M. Nobody does, and that's the first thing they'll say, that nobody really knows where that came from, but people think that maybe that's where it came from, because it's been around for a really long time. All right, so anyway, we use M for slope, and I'm going to write this. Now we know slope as what? Rise, talk to me, over run. Okay, and that's a good way to think of it. There's nothing wrong with that at all, but we're going to make it a little fancier. Instead of rise over run, we're going to put this triangle. What's that triangle? It's not really a triangle. It's a Greek letter of the alphabet. Do you remember what that is? It's not pi. You know what pi looks like. What is it? It's delta. Very good. All right, that's a delta. All right, so delta y, or the change in y. We use delta to represent the change in something. All right. If I find the change in something from here to here, right, let's say I'm at mile marker 10 here, I'm at mile marker 2 right here, what's the change in your distance from 10 to 2? It's 8, right? So what did you do? You subtracted, didn't you? All right. A lot of times they write y2 minus y1. And then what's the change in x? This would be x2 minus x1. Notice, you took the second y minus the first y. Then you had to take the second x minus the first x. Or, if you wanted, it really doesn't matter what order you subtract. All right, as long as you subtract them in the same order. So if I go y2 minus y1, I have to go x2 minus x1. Or I could do what? y1 minus y2. If I decide to subtract that way, what does the bottom have to be? It has to be x1 minus x2, right? Everybody good with that? Most books usually teach y2 minus y1, all right? I get it, because watch. If this is 2 and this is 10, this is your x1, this is your x2. Wouldn't you normally go 10 minus 2? Yeah, so that's why they say x2 minus x1, all right? But if I go, if right here, if it's 10 and 2, if I go x2, it's a positive 10, what would I get here? This would be a what? A negative 10. But if I go the other way, see, it's going to switch the sign. So if this happened to be positive, this would be what then? Negative, all right? You with me on that? That's the only thing that changing the direction that you subtract does. Yes?
Where do you get the y's from?
Because of this. If I wanted to find the slope, that's my rise, correct? And that's my run. Well, where are we here? We're at 2 on the y here. We're at 0 here. What did I subtract? 2 minus 0. But I subtracted the y's. This is the y value. What about this one? That's at 3 and that's at 0, correct? All right, so what did I subtract? 3 minus 0, that's the x's. All right, so I subtract the y's because that's the rise, right? The y is going up and down, and the run is going across left and right. That's the x value.
So you add up all the points until from the origin to the...
I just count. From here to here, that's 2. Look, I could have gone, well, I got to find a point. I could have gone like from here to here, couldn't I? Gone down this way and gone across that way, and it would still come out to 2 over 3, all right? Because that would be like 4 over 6 or something like that, okay? Oh my goodness, I can't believe we didn't finish this. We took too much time going over the homework. Well, yeah, I hate to assume that you already know how to do this stuff. I can't really work on that, but I bet you anything that you guys could do the homework right now. But I'll finish it tomorrow, all right? So I'll tell you what, I'll write it down. If you want to give it a shot and get some of these done so you don't have so much to do tomorrow, it might be a good idea, okay? So if you have time tonight, get as many of these done as you can. If you can't do them, we'll finish it up tomorrow, and I'll sign it then.